All right, this is the application portion of 4.5 exponential and log equations. This is continued. So we are doing applications here, word problems. So I'm going to do a compound interest problem. And then I'll have you try one, and that will be it for this video. Just this one problem and then one for you to try. All right, so a sum of $5,000 is invested at an interest rate of 5% per year. Find the time required for the money to double if the interest is compounded according to the following. A, semi-annually. And then B, continuously. All right, so we already know that continuous compound earns more interest. So, but let's see how much longer it takes for this one to double compared to that one. All right, so what do we know? We know our principal amount. This is our P value right over here. Let's highlight some of these things. All right, so right here, this is P. Right here, this is R, but we want the decimal version, so it's going to be 0.05. And then double. So this is A, 10,000, right? If it doubles. Okay. And then what else? Okay, I think that's everything. And we have to find T, right? Find the time T. We don't know what that is. All right, so this one, we have an extra thing, N, semi-annually. So over here, this is N equals 2. All right, so let's go ahead and do the work. All right, so this one here, we're going to use this formula, A equals P times 1 plus R over N to the N times T, and we'll be solving for T. Okay, so this is the formula we're going to be using here. And for continuously, we will be using this formula here. And again, we will be solving for T. All right, so we said A is 10,000. P is 5,000. 1 plus rate was 0.05 and is 2. And then we have 2t here. Okay. All right. So over here, we're going to go ahead and divide both sides by 5,000. We can do that. So here I get 2 equals 1 plus 0.05 over 2 to the 2t. And then over here, I get 2 equals 1.025 to the 2t. Okay, so here I have to solve for t. T is wrapped up in here in this exponent, so I have to take the log of both sides. This is an exponential that you're trying to solve, so you have to take the log of both sides. Okay, doesn't matter if you use common log or if you use natural log, ln. Okay, so log 1.025 to 2t. And now we can bring the 2t down to the front. Okay, this is all multiplication with t, so I'm going to divide by all of this except t. Okay, so let's divide both sides by 2 log of 1.025, and that will cancel, and this will cancel. Get it all done at once. Okay, 2 log 1.025. Okay, so here, when you everything cancels on this side, so we're left with t. And when you punch this left side into the calculator, we get 14.04. So that's how many years it will take, okay, on this side. All right, let's take a look at how long it will take for continuous compound. All right, so 10,000 equals 5,000 e to the 0.05 t, and we're solving for t. Divide both sides by 5,000. Get the exponential by itself, right? 2 equals e to the 0.05 t. We're solving an exponential, so we have to take the log of both sides. So here, since that's a base e, I'm going to use ln this time instead of common log. So I'm going to take the natural log of both sides. And that will cancel out. So we get ln2 equals 0.05 t. And then divide both sides by 0.05. And so here, if you punch that into your calculator, the left-hand side, you get 13.86. Okay, so that's how many years it will take if you use the compound continuously account. Okay, 13.86 years compared to 14.04 years. A little bit faster, which we knew it would be. Okay, all right. Go ahead and try this one. All right, $1,000 is invested at an interest rate of 4% per year. Find the time required for the amount to grow to 4,000 if interest is compounded continuously. Okay, so again, continuously, that's the magic word right here. This tells us that we are going to use this formula as opposed to the other one with the ends. Okay. All right, so we know some things here. Um, this is your initial amount. This is your interest rate, but we want it to be in decimals, so 0.04. We're trying to find time, and this is A. So you have everything you need to solve for T. Okay. All right, so A is 4,000. Oh, you're supposed to do this. Okay, so go ahead and hit the pause button and try to work this one out. And then come back and see if you get the same answer. Okay, so if you solve this, then you should have gotten 34.66 years. If you didn't, then stick around and watch. Okay, so that is our final amount. Initial amount was 1,000. E to the points, was it 0.04? Yes, 0.04 t. And we're solving for t. All right, so let's get the exponential by itself. Divide both sides by 1,000. And we get 4 equals e to the 0.04t. We are solving this exponential, so we need to take the log of both sides. I'm going to use ln since we have e here. And that will cancel. So we get ln 4 equals 0.04t. Solving for t, divide both sides by 0.04. Okay, when you punch that into your calculator, you should get 34.66 years. Okay, so that is it for this video. Just a short example of how to use this in applications. Okay, see you next time.